Good morning, Shashank. We'll get started. So the app is running and we have here timer and I just want to shut it down. So let's clean that up here. We don't need this, nor do we need this. Anyway, so today we'll see unit testing of Angular application. See what is unit testing, we'll get acquainted with it and the framework that we use. We'll learn some of the basics of that framework and then start testing this Angular app that we have written. Usually you will write unit test first and then write feature, but anyhow we have completed writing our application and that doesn't make much sense in course, writing a test first and then writing functionality. So let's see what I mean to say is, and that is called TDD, test driven development. Go to app folder and somewhere in the shared folder, I would like to add one file by the name calc.ts or math.ts. So assume that this is just a calculator file which will have add or subtract functions. That's it. So I'll create a class and export it, math, and this will have add function, which takes two parameters and returns me the result. So I'll say subtract a comma b and does. So see, I'm not writing the logic. So let's try to do TDD. So we don't have any logic in that function. Now first we'll write the test and then we'll get into writing the actual logic. So I'll say math.spec.ts. Spec sometimes stands for test. So people call them test or specs. Doesn't matter. So this is the naming convention usually the Angular developer follow, math.spec. Okay, here you will import the file that you want to test. So the math is your file. And the framework that we will use for testing Angular or JavaScript is Jasmine. So it's not specific to Angular. You can test pretty much any JavaScript code using Jasmine. So the first function we'll learn in Jasmine is describe function. So describe is a function which takes two parameters. If you notice the IntelliSense, description of this block and spec definition, which is a method or an arrow function. So here I'm going to say math or calculator, whatever the description is. It is in plain English, so you can write whatever you want. And the second one is a function or arrow function. It's up to you which one you want to go with. And here you will have it. It also has two parameters. You will say it should add two numbers and return result. If you notice, this is plain English format and it's up to you how you want to form this statement. But as long as it makes sense and it is meaningful, that is fine. It should add two numbers and return result. And the second parameter is function. That's where I usually write my test. And it function is where usually we write tests. And describe function is kind of a block. So you're organizing things. And here I'm going to say expect. Okay, so when you're writing test, you tend to follow this pattern or these steps. Triple A stands for act or arrange, act, and assert. So you arrange the environment, whatever it is. So we want to test math. So I'm creating an object. This is like arranging the environment. Whatever it takes to arrange, you set up. Arrange phase is like a setup phase. You set it up, and then the second phase is act. So you act on something. So you're interested in testing the add function. So you say add 1020. And then finally, assert is what you're trying to check out of this test. You'll say result to be 30. Okay. So far we have learned three functions in Jasmine. Describe for organizing your test. It, the test itself. And the third function is expect. So what you expect. Expect takes actual result and expected result. So you have expected result and you have actual result and expected result. You are expecting the result to be 30, and this is the actual result. When your actual result and expected result set to be same or equal, and that's when this test is set to be passing. Otherwise, it will fail. So let's run this test. Let me kill this server. Say ng test. Ng test runs the test. So remember, we haven't written any logic in this add function. So this test will fail. Certainly, it has to fail. So, and this process is called red-green refactoring. So usually your test would, when you write it, it would be in red phase, which means failing phase. And then you refactor it and take it to green phase. So that's red-green refactoring. And usually that's how you write the test. There would be a failing test, and then you write code or you refactor just enough code to make it pass, and the test will pass. So that's TDD in a nutshell. Okay, so the test is failing. The reason is we are trying to catch something and it is not available. But no matter what is the reason, the test is failing. So we are in red phase. So now I need to make it pass. I'll go back to my source code and write enough code just to make it pass. You'll say A plus B. And with this one change, now you will have a passing test. So this opens up a browser because your Jasmine test runs inside a browser, and there is somebody who is running these tests. That's Karma. Karma is like a platform or a tool which takes JavaScript tests and runs those tests. So Jasmine is a framework to write tests. Karma is something, a tool to run those tests. So Karma is not specific to just Jasmine. You can run different types of JavaScript tests. So it's like a technology agnostic. See, now our test is passing, 1 of 1 success. So this is what TDD is. So you write a failing test and you write just enough code to make it pass. What's the advantage of following this practice is you will not write lot of code or useless code in this add function. You will write only that code which is actually necessary to make this test pass. Okay, so now your business came up, the add function is working fine, and your product owner said that he wants to add a new feature to this add function, saying that when the first parameter is 0 or less than 0, it should return a result as 0 without adding anything. So just a silly business requirement that's not important anyway. So the what how I'm trying to write the code for that is important. So let's see. So I'll say it should return 0 when first parameter is 0. So that's my business description of the test. And the test itself is going to be written inside a function. And in this function, I'll arrange the phase. So I'll say math, new math. I'll act on it. What I'm trying to test, add function. So I'll add it. I'll say first parameter 0, second parameter 100 or 1000, whatever it is. And then what you expect? You expect the result to be 0 because that's your description. This test will certainly fail because we don't have logic for this. We haven't handled this case. So you will start with a failing test. You'll realize that test is failing. Now you'll go back and write the code for that. See, the test is failing. When you go and see the result or the error message, it says expected 1000 to be 0. So you're expecting the 1000, the actual result, to be 0. So your actual result and expected result are not equal. So you go back to your source code and you write just enough code to make it pass. That's it. Nothing else, and this will make that test pass. See, the test is passing. Now again, in future, this method is working fine now. In future, your product owner came up and said that he wants to add a new feature. It should return -1 when second parameter is 0. Again, silly business requirement, but that's not important here. So I'm just trying to get acquainted with the syntax and the way that we should do TDD. I'll say math every time you arrange the environment, and every time I act on it, I'll say math.add, I'll say 1000 and 0, because my second parameter is 0. What I expect the result is, according to my product owner's business requirement, I'm okay, -1, I'm sorry, not 0. So I've written, okay, yeah, that's fine. It should return -1, and that is what I'm expecting. Save this. Your tests are running. Karma is running continuously. It's looking for file changes, and this test will fail. We're starting with a failing test. Now I'll go back to my math.ts and try to make it pass. I'll say if b second parameter is 0, just return -1. See, now we have a passing test. So what's the advantage of writing these tests? The advantage is you will be more and more confident about refactoring. If some developer came and modified this logic for some or the other reason, you will have a failing test here, because the you have written the logic for that, or you have written a test for that. See, there is one failing test because somebody has just modified something. So it's like you're getting feedback saying that, okay, something is wrong. Your specifications doesn't match with your code. That's what it means. If there is a failing test, which means you are saying something in the test and you're doing something else in the code, and that doesn't match. Every time it has to match. So this gives you a lot of confidence, no matter in which stage you are. Even if your code is running in production, you'll be still able to refactor your code, because we write code and probably after some time, after a couple of years or maybe a couple of months, we get some more knowledge, and then we want to improve this code. So if you don't have tests, you would be afraid to improve this code. The reason is you may lose your job just because you're modifying something and you haven't tested properly, and that may break in production, and production bugs are very serious in nature. So we know what happens. So that's why no matter in which stage you are, it may be staging environment or your application is very, very critical, running in production environment, still you will have some confidence to refactor your code. So this takes some time. Writing test is not going to come for free. It takes time, it takes efforts, but again, in long run, this is going to help you a lot. So that's why product-based companies tend to follow this TDD, while service-based companies, they're not really foresighted. They're just short-sighted. So they just worried about this time that they spend. So you don't really see people writing tests in service-based for the most part. Product-based companies realize the importance of tests, so they write unit tests. Okay, so now the question is, how many tests should I write? Now let's go ahead and write a test for this subtract also. So for subtract, I'll say it should subtract two numbers and return result. Let's go with arrow function this time, just to show you that you can even write arrow function here. And you'll go with the same phase again, new math, and then you act on it. Say 2010, and what you expect is 10. And we have a failing test for sure. So go back to math.ts and try to fix that issue. So you're going to say return a minus b. This is the correct way of doing TDD. You write test first and then you write code. But somehow in this course, we didn't do that. There is a reason behind that. We wanted to learn concepts. We are not actually writing a production level application. So that's why we couldn't do it, and we can't do it now also. But I'm just showing you with this file. Okay, now, okay, certainly this test should pass. Okay, the reason is I modified this. So that's what is failing test. Just fix this. Now we should have a passing test, but I don't see that. Expected 1000 to be 0. Anyway, now we have a passing test. Now we'll write one more test regarding this subtract. Your product owner came up and said, if the second parameter is greater than first parameter, you just return 0. I say it should return 0 when second parameter is greater. Just that's my business requirement. And I'm going to say same thing, arrange, act. While acting, you have to be careful. So what, according to your specification, you should pass the parameters. So I'll say 10, 20. That's actually says everything, that the second parameter is greater. And I'm going to say expect the result to be 0. So according to the current logic that we have written in our subtract function, this is going to return minus 10, but my product owner says that that should be changed. So you will start with a failing test. I'll go back to math.ts and try to modify it. If you see the error message, it says expected here minus 10 to be 0. So come back here, you'll just check if A is less than B or B is greater than A, something like that. You just return 0. Simple enough. We are writing only that code which makes that test pass, and we are not writing any junk code here. We have a passing test. Okay, so I'll go ahead here and I'll say if A equals to 0, return minus 1. So I'm not writing test for this. There is a reason behind it. I want to show you something. So assume that I'm not writing test for, okay, not assumption, it's just the truth. There is no test for this line of code. So how many tests should I write? When should I stop? How many tests are the correct amount of tests? How many tests are too less and how many tests are too many? So how would I know that? So for that, you have something known as code coverage. So that gives you, the code coverage report gives you like what's going on, how many lines of code has been covered and how many lines of code has not been covered. So let's see, I'll say ng test, I'll say code coverage is the flag, or if you want to go with short, just say -cc code coverage. So this will generate a code coverage report for you in your application. So Karma, as I said, it's a tool. It runs inside Chrome, but you can make it run inside Edge or inside Firefox and so on. This tool has its plugins for Firefox, but it doesn't really matter as long as it is running in Chrome. That's okay. I don't see any reason to run these tests in other browsers because they are just back tests. So nothing, user is not going to see anything. But when you're testing your UI, it's a good idea that you test in all the browsers because browsers differences matter there. But as long as unit tests are concerned, Chrome should be fine unless you find a specific need. So if you see here, coverage report is created. Now go to index.html, just say reveal in Explorer. Open this without any server, just open using the file protocol. So here it is. See, now I have my code coverage report. Just go to app shade and I want to see math.ts. So how many lines I have covered? Only 93%. The remaining 7% is missed out. How many functions I have covered? All of the functions, all of the lines. How many branches? Branches means if else conditions or switch case statements, only 87%. So it looks like there is an issue here, and 93% statements have been covered. So go to math.ts if you want to see more information. See, it says this line of code has never been covered. So this is missing if you see the red line. So I have never written code for that. That's what it is telling me. So always try to cover as much code as you can. Now go back to our test file and try to write code for that. I'll say it should return 0 when first parameter is 0. I'm again saying these requirements are silly, but they honestly makes you learn something. So I'm just going to save some time by copying and pasting it. The first parameter is 0, and what I expect is 0 or -1. I'm sorry, it should be -1. Okay, now it is passing. Go to coverage again, go to Firefox browser, just hit refresh. See, we have 100% covered. Now you can stop writing test for this because you have covered everything this file. And this is very, very healthy code coverage. So it's like you have covered pretty much everything from this file. Anything, any modification to this file may fail the test and will give you feedback saying that you're doing something wrong if you modify it. So that's how you should write tests. And it is in real world application, in enterprise level application, it's impossible to maintain 100% code coverage because of the huge code that you have. So people consider 80% as a good code coverage, a healthy code coverage, anything 80 or 80 above. Anything less than that, you should focus on improving the code coverage. Anyway, our application is simple. So it's easy to achieve 100%. Okay, so now if you analyze the code here, there is a lot of duplication. So again, I'm creating an object every time. Can't I just create an object here and use the same object everywhere? I can do it. But again, that's going to be a little ugly because every test is independent of another. So the result of this test should not influence the result of this one. So both the tests have their own outcomes and they are independent of each other. So that's why I'm providing a clean environment each time. Clean, I'm creating a new object and uh, I'm giving us new environment to this test. So that's encouraged. You should not create only once because it's going to mess up. You may have some state or you might have missed some cleanup logic. So it's a good idea that you start from scratch for each and every test. But this duplication logic can be avoided using a function before each. So this is the fourth function we are learning. Before each takes a callback function, and here you'll put it this here. And if you want to access math, you'll just say var math. And each time this function would execute for each and every test. So I can simply get rid of this math.ts. Okay. Now there is no duplication. I cannot make it again common because it has the varying number of different parameters. So that's how before each is used. And even after this change, this will not break. As the name suggests, this function will execute for each and every test. How many times this function will execute? 5 times because we have 5 tests in this file. Probably 6 tests we have. So 6 times this will before each will execute. The same way, if you want to clean up the environment, you have something like after each. Inside after each, you'll just say math equals to null or undefined, whatever it is, just to make sure that you're creating an environment and cleaning it as soon as the test is done. This will also execute 6 times because after each and every test, this will execute. Just say in after each. So you'll have this console log statements logged somewhere. Every time this logs in. Okay, one more thing is the debugging of these tests are no different from the debugging of your application. If you want to, for some reason, you have a complex test and you want to debug it, you can do it. Go to sources. You should find the source of your uh, file. So math.spec.ts and math.ts both are loaded, and you can put a breakpoint here and you can debug it as usual. So it really helps. Sometimes we don't know, we are not sure what's going wrong with test, but if you want to debug it, that would be a good idea to find out issues. That saves a lot of time. Anyway, so that's about the Jasmine. Little bit of description, 5 functions we have learned: describe, before each, after each, it, and expect. And these are called matchers. So you're matching the value to be, and we have different kinds of matchers. We'll talk about them as we progress in this session. So now let's close this file, go back to our Angular application, try to test our components, because that's the whole point of learning this math.ts. This file doesn't serve any purpose. Math.spec doesn't serve any purpose, just for learning. So one more important thing to remember is, in unit test have to be fast. So there are some qualities that a unit test should possess. That is fast. It should be fast and it should be simple, and it should not be making any DB calls or web service calls, because you'll have thousands of tests. It doesn't make much sense to make DB calls and modify the database and all those things. So actually we make web service calls from our Angular applications. How are you going to test them? Using fakes. So you fake the DB call as if it is making a database call, but it actually won't make any web service or database calls. And it has to be simple and it has to be independent. So every test should be independent. So even if you're running all these tests in parallel, they should give you the same outcome without any dependency. If your test has a dependency on another test, and that's kind of a ugly way of writing tests. Okay, so now one last thing is, uh, if you want to write, or if you want to skip some test, you can put xit. Xit is again a Jasmine function. It just skips those tests. I'm going to remove this console log statements. It says skipped one. And if you want to run only one test without skipping, by skipping all of them, you'll say FIT. FIT helps you run only this test. Okay, why is it failing? It's okay. Now it is passed. All of them are skipped. The entire test from all the files would be skipped except this FIT. And that's FIT XIT. And then if you want to run this block, you'll say fdescribe. Okay, which command makes test run? It's ngtest. Ngtest is one. Ngtest minus cc is for code coverage. If it generates even code coverage report also. Okay, 6 of 6, all are passing. But if you, again, one last thing we'll see in this math.spec is grouping the test. And I don't know which method this test belongs to. If I open it, then I'll see, okay, subtract. So you can have as many describe blocks as you want, and kind of that helps you organize things. So let's go to describe, or create a describe function and say add. This will have another function. And I'm going to move all the tests here. Now, can you see this? This describe block belongs to add. And the same way, I'm going to create another describe block for subtract. So like this, you can have as many describe blocks as you want, as long as you're trying to organize stuff. And every describe block can have its own before each, its own after each, like this. Even after this change, we should not be seeing any difference in the outcome. It's just that you're organizing. Describe block doesn't matter. Actually, this is only for organizing your test. What executes is this it function. That's it. Jasmine will, or Karma will look for this it, and it runs those tests irrespective of number of describe blocks you have. And if you want to run only tests related to this subtract function, you can put fdescribe. That will run only this block, not the remaining blocks. from any of the file. And if you want to skip this block, you'll say X describe. Remember that X prefix and F prefix for test and describe. Okay, so enough of this. Now let's commit these changes, get back to some real stuff. So this was the simplest form aimed at delivering just a syntax of Jasmine. Now go to home component or whatever component is easy. We'll start with the easy component first. Let me see what we have in home component. Actually, we have a lot of things, so let's not worry about that. Go to about component.ts. Yeah, this looks clean. It doesn't really have anything. So what I'm going to do is I'll have a counter variable, say it's a number and it is initialized to 10. So I want to test this. So remember, I'm not going to test template. I'll be testing only class here. So you can test templates also, but depends on your project requirements. Some people want to test template and that's going to be complex again. And some people just want to be making sure that the class level variables or properties or methods are working fine. So we'll see the other way, which is testing the component. So here in the about folder, I would like to put my specs. I'll say about.component.spec.ts. So look at this. I mean, this about folder is like a feature. In this feature, you have your template HTML file, you have component file, and you have your test file as well. Everything goes inside this. And this is the code organization that is actually encouraged by Angular team. Anyway, grab first the component that you're interested to test it. About component. And the next thing I need is describe. So what you're describing? You're describing about component. So you will have a before each. Just go with arrow functions, makes it easy. And the same way I'll have after each. This is like my skeleton. So this IDE supports code snippets. So if rather than doing this every time, you can create a code snippet, and with that shortcut, you can generate this skeleton. Okay, so I'm going to test my component. I'll select component. That's undefined. And I'm going to say component equals to new about component. This is a component. End of the day, it's a class. So I can use new operator to create a component class. That's my arrange phase. I'm arranging something. And the next is I want this component to be null once a test is completed. In before each, I'm setting the environment. In after each, I'm cleaning that environment. And the test says, what should I test now? That's a big question. So this class is a very, very simple class which has only one property and whose value is 10. So what you should test is it has this property and it is defined and it has value 10. So that's your test. Let's go ahead and do this. Say it should have counter defined. You'll say expect component dot counter because it is on the component class. You say component dot counter to be defined. So to be defined is another measure. You know what is defined and undefined. If it doesn't have any value, it would be undefined. So you have to be defined and to be undefined measure. There are many, many matches available. You should go through the documentation to find out what makes sense for your requirement. Anyway, see, we have a passing test. And I want to be more explicit and write another test. I'll say it should have counter set to 10. So one test, one expect. That's it. That is encouraged. And remember, we don't have any act phase here. The reason we don't have any act phase is here. We are not calling any method. As soon as an object is created, this counter would be set. So there is no need to act. Arrange and assert, two phases are enough for this test. I'm going to say expect component dot counter to be 10. See, I have 8 test passing. Like that, you write test. And now if you have some logic inside some function, say you have increment function and you are incrementing it, you'll say this dot counter. Assume that this counter variable is used inside your HTML. Let's go and use it. Say h3 counter, something like this. I'm not running this application, I cannot show you, but this would bound 10. Now, when somebody clicks on a button and invokes that event, let's go ahead and create a button and click event, which in turn calls a increment function, say increment. And when somebody clicks on that button, it actually increments the values. To show this, let's run ngserve. We'll come back later because it takes some time to compile and run the application. Meanwhile, we'll go ahead and write test. So you can write another describe block if you want to for that increment. So I'll say it should increment the value of counter by 1. First, I'm arranging it. Before each has already taken care of arranging, I'll act on it. Now I should act because this is a method. So I'll say com.inc. Once this is called, you expect the value of counter to be how much? 11. The reason is this will start with a clean slate, and clean slate will give you value 10 for counter, and then you're incrementing it, which means it should be 11, and the test seems to be passing. So if you have noticed, the way I'm writing the description is a little odd here. Should, something like that. Go back to math.spec.ts and try to read it from top to bottom. So I'll expand this block. So you should read from top. You'll say math add function should add two numbers and return results. Math add function should return 0 when first parameter is 0. From top to bottom again. Math add function should return -1 when second parameter is 0. Doesn't that sound like a document? It is. It is a document. So you will not have any technical documentation for your project. Agile is against having documentation for your project. So this is your documentation. Any new developer who joins the company would go and read the test if he wants to find out what's going on with this math.ts file. And this is great way of writing document. So you will not spend any extra time maintaining all that big documents and dealing with all those things, and whenever something changes you need to go and modify it. Here it's easy. The reason is probably you're writing the documentation anyhow here, but the difference is you will write the documentation feature by feature. So you work on a feature and you write very minimal amount of documentation. So it's not like you're sitting and wasting your time just for writing document. So that's a very important thing, and this really helps. So the convention is you'll say should, and so on. Anytime you write a test, it's a good idea that you write it more descriptively and which makes sense whoever is reading, because the new developer comes in, he'll read the test and he'll understand what's going on with certain file. Okay, we'll stop with this about component, and that's how you test your component. This was a very simple component. About component, if you go back and check one more time, it doesn't have any dependencies. It's just a simple independent component. Now what I'll do is I'll make this component or go to home component. Let's try to test that home component. We don't need this. Okay, there is a lot of things in going on. This may confuse. So let's go to about component and try to modify this and make it a dependent one. So this component is not self-sufficient. Rather, it needs a console logger. So I'm adding one dependency. Or just don't ruin this, let it be there. go to contact component and try to modify that component. Assume that this contact component has a dependency now, console logger, and in ng on init method, it logs something to the console. It says test logging, whatever it is, just okay. Simple component. Now it has a dependency. How am I going to test this component? And this is going to be interesting. Let's go to contact folder and try to create a test file. So say contact.component.spec.ts. First thing first, you import the component that you want to test. And then you'll start with a describe block. You'll say contact component, and you'll have a before each loop, function. And the same way, we will have an after each. And you'll have a component reference. And this component would be initialized from before each. Say component equals to new contact component. There is an error. Let me finish this null. So the environment setup is going to be little complex here, the arrange phase. The reason is this component has a constructor which expects one parameter and you're not passing it. Can I just pass this logger? Say let logger, and the logger is going to be logger equals to new console logger. I believe I can, but again, that's kind of you're breaking the principle of unit testing. Unit test should only test this file, contact component, not its dependencies. Whenever you're testing something, you should focus only on one file because it's unit test. You'll test piece by piece. You'll not test the entire flow. So, which means when I'm testing my contact component, I should not be worried about this logger at all. You should assume that it doesn't exist at all. You should focus on the existing logic in this file. So what's the solution for this? Even though I want to ignore this, I cannot ignore because of the language principles. The constructor needs a parameter, you need to pass it. That's it. So in that case, I'm going to pass a fake object. So when I cannot get away from passing an parameter to this constructor, I'll pass a fake object. So let's see, I'll say logger equals to Jasmine lets you create a fake object. You'll say create spy object and name of the method. That method name is not, I'm sorry, not method name, that's service name. It can be anything. I'll just go with service. And the second parameter is your array and the fake method that you want to create in this. Why am I creating only one fake method? Because that's the only method that I'm interested in this. So that's your environment setup, and I'll pass this logger. See, arrange phase is done. No compile time errors. Now arrange phase is completed. Now I can focus on writing tests. So when there are dependencies, the arrange phase is going to be a little tricky. That's it. The other phases are going to be pretty straightforward. So I'm going to write the test. I'll say it should call in ng on init. It is actually calling logger.one method. So I'm making sure that this method is called, and that's what is expectation. So I'll say it should call logger.one method. That's it. So do I need to act on it? Because this is a lifecycle hook. When you're running Angular, it would be automatically called. And I have arranged already. Do I need to act on it? Yes, you need to act on it because this is not Angular. The test that you're writing is outside of the scope of Angular. So Angular doesn't know what's going on, and Angular will not invoke this ng on init automatically. So you need to invoke yourself. So you act on it. You'll say ng on init. And then what you expect is you expect this dot logger not this dot, that's my bad. Logger, which is a fake object, one, which is a fake method to have been called. So this one may have database logic, may have web service call. We don't really care because we have faked it. This is a fake method, and I'm just expecting that that method is called. That's it, nothing else. So this is another matcher. You'll say to have been called. Now I want to be more specific, and I want to see with which parameter this is called. So I'll say to have been called with this parameter. If I say test logging 1, this will fail. So it's always a good idea that you go with specific parameters rather than just saying to have been called. You'll say to have been called with. See, now there is an error, and if you see the error, it says expected a spy, fake, stub here, everything means same in this case. So you're expecting this to be called with this parameter, but actual call is with this one, like that. So that's how you write test for this contact component with dependency. So let's save this. I'll say contact component specs. Okay, with this knowledge, now let's move forward and test even more complex component. I'll go to product detail component. Here I have, here I am, and inside constructor, I'm calling this product service dot get by ID, and it has a dependency of two things. Product detail component is dependent on two things. First, let's go step by step, and don't worry about what to test. First, set up an environment. So I'll go ahead and create a test file. Let's say product detail dot component dot spec dot ts. I'm going to say product detail component. Describe it. And the same way, it's going to be a routine thing. So just grab component, and then you'll say before each, it's going to be a function. And the same thing I'm going to say for after each. This is going to be a function too. So in this, I just want to say component is null, and I want even the dependencies. Go back and check the code. I have product service dependency, so I'm going to just say service here, let svc, and I have a router dependency also. I'll say ret route or activated route, whatever it is. And now in my after each, I want to clean everything. Route null. That's my after each, and I'm not going to touch it anymore. And in before each, I'm going to create an object of this new product detail component. Okay, now there is a problem because of the two parameters that are missing. First parameter, I'm going to create an object of service. I'll say new, not new, using jasmine.create spy object. I'll say jasmine.create spy object. I'm going to say some method name, and the method that I'm interested in to fake is get by ID. I'll say get by ID. And this is first parameter. The second parameter is the activated route. What I'm grabbing it from the ID. So whatever it could be the ID. So I'm grabbing it, and this is on route snapshot params ID. If you notice, get by ID is a fake method. While there is no method on this service, it's all properties. When there is no method, you don't need to fake the method. You can fake the property easily. You'll say route equals to this object will have snapshot property, params property, and ID property. So snapshot params ID. I'm just saying ID 1. Very simple. No need of creating a spy object or fake object, something like that. It's just a property, and the property should be available, because when you pass a fake object in route, it should have snapshot object, params object, and ID property on it. If snapshot is missing, you'll get a null reference exception. Okay, with that in place, I'll pass this route and we are good to go. That's our arrange phase and little more complex than what it used to be. Now I can focus on writing test. Now you think what to test. First thing, there is a declaration product. As soon as I create an object of it, I want this product to be undefined because this is undefined. So let's go ahead and say it should have product undefined. One more thing, yesterday we have learned about the lifecycle hooks that you should not write this code here. So let me get rid of this. It should go inside ng on in it. So I'm going to fix that issue. And this dot product service. Okay, so that's a fix and the constructor is clean. This product is undefined and that's what I'm testing. I want this product should be undefined. So how you expect it? There is no act phase. You'll say expect component dot product to be undefined. It should not have any value set. That's my specification. And if everything goes good, you should have a passing test. Certainly you have one. And the next thing, what to test is the ng on init hook. So inside this, a lot of things are going on. First, it actually grabs the ID from snapshot params. It actually comes as a URL parameter. And then it actually making a call get by ID of product service to get the data by passing that ID. So here I can test whether this method is called with this ID or not. That's what my goal is. Let's go ahead and say it should call get by ID of product service. First thing first, we can write a lot of tests in this for this piece of code, but at this moment we'll go with this one. So it should call get by ID of product service, and then I expect that to happen when I call ng on init. I'll say expect product service is nothing but service here. That's a fake object, and I'll say get by ID to have been called. We have passing test. Okay, I don't expect this to pass. Yes, we have a failing test. The reason is it says cannot read property subscribe of undefined. If you go and without even debugging, you'll know that this get by ID returns an observable, and on top of it, I'm calling subscribe. And something that's where it is messed up. So this get by ID is returning undefined, and the subscribe calling and the function subscribed is called on undefined, and you're seeing that null reference exception. It is because of this fake object. You're creating a fake object, you're creating a fake method. Probably I told you once, every function in JavaScript returns a value that is undefined by default. So this get by ID function is no exception. So it returns undefined by default. So what you should make it to return an observable. It should return observable according to your code. So when you're creating a fake object and a fake method, you should be careful that you return what actually your code is expecting it to be. It's kind of you're completely creating a fake environment as if it is actual environment. So I'm going to say get by ID equals to jasmine dot create spy method. This is not an object, and you'll name this method something, and original function. So you will say and return value. What it returns is an observable. So I need to create an observable. We have learned how to create an observable. This test is going to be complex. Just bear with it. So I'll create an observable using new observable, and this observable will have something like this. Say o dot next 10, o dot next 20, o.next 30 or whatever it is. And we have learned that you can create an observable using new, and you can call next object on it. Doesn't really matter. It doesn't necessary that you should always pass a web service response. It's okay to pass something like this. See, now I'm saying it returns an observable, and this should fix the issue. So this is where the test goes complex, and that's why unit tests are hard to write. It's very complex. When I started my career, it took me 2 months to understand what's going on behind the scenes in the test. So unit tests are always complex because of this faking. You're trying to create this fake environment and it's not easy. So again, it doesn't mean that it's impossible to master it. So spend some time looking at this and why certain things are done the way they are, and pay attention to it. Tomorrow we'll discuss end-to-end tests, and end-to-end tests are far more easier than unit tests. Unit tests are complex, but again, they're worth it. Writing unit tests are worth. See, now we don't have that null reference exception because we have created a fake object, fake method, and we have even said what that fake method returns, a fake observable. All is faking. And with that observable, you have a subscribe function on it, and this response would be set, and you will have your test passing. So go ahead and write the test. Try to return a response which actually has response.reviews, something like that. Because we are not testing this code, and this test is going to be very again straightforward. It's just that you need to return an observable of an object which has some test. I mean some reviews and product and all those things. Anyway, we'll stop here with respect to this product detail component, and that's how you fake an observable and return type. So we are not actually testing the error condition. You should return o.error and the error message to test this line of code. This because this will execute only the success part. The error part, you will have a code coverage missing for this. And you give it a shot. So we have a couple of more minutes, and I want to test the service and end the session. Go to product service .ts, and I want to test something like this, or delete function. This is the easiest one to test it. So go to shared folder and try to create product service.spec.ts. I'll copy and paste to save some time. Copy everything and paste it here and get rid of most of the stuff. So this is going to be product service, and this is going to be product.service, and this is going to be product service. Now product service also has a dependency of HTTP. So I'll say service is my actual service object, and I'll say HTTP, which is my fake object. So I'll say SVC. HTTP is null. So I'm just doing the same thing what we have did so far. It's going to be HTTP. I'll create a fake HTTP object. I'll say jasmine.createSpy object, and name of the object I would like to go with HTTP. And what I would like to fake is get, post, delete. All these methods, I want to create a fake method out of it. And get rid of this. Now try to test that delete function. What it should do, when you look at the code, you'll understand. HTTP.delete, it is calling a method from the HTTP service by passing this URL. That's what I want to test. So I'm just going to say expect service.delete. This is the act phase, and I expect HTTP.delete method to have been called. So we have seen quite a few matches. As I said, there are a bunch of matches available. You should go through the documentation to find out all of them. Let's save this. We have a passing test, I believe. So that's our product service test, and go ahead and write test for all of these. So this product service, logic wise, it doesn't have a lot of stuff here, but it can have some more code also. In get, we are returning the data that is coming from this service response. But if you want to modify that response, you can use map operator. We have learned that when we were discussing observables. We have learned about map operator and filter operator. All these operators, you can have it and you can do stuff. Or if you want to catch errors, you have catch operator in this on this observable, and pretty much you can do this. But for our purpose, this is sufficient. We want to return an observable, we are returning. But some, for some or the other reason, if you want to transform the response, you can use certain operators. So let's commit these changes. So I'm going to say product service specs. So by no means this is a comprehensive description of unit testing. There is more to it. You'll have more and more complex scenarios, but again, this should guide you in a right direction. So how to fake something, how to get something done by faking. As when you master the faking, that's when you'll master unit testing. So one more thing to remember, we are not testing HTML in any way. There is one way. So when you go through the documentation of Angular, you'll find out how to test it. But again, some companies tend to test HTML, some companies tend to don't test. It's nothing like a silver bullet. So you just choose what works best for you. Like there are pros and cons for each and everything. So I think that's it for today. I'm done. Tomorrow, I mean, on Monday, we'll see how we can test this end to end. Unit test, not unit testing, but UI testing. So we'll use Protractor to test that. And if you want to know the configurations and all those things for this test, karma.conf.js is the file. That's where the configuration is there for Karma. Go through this and you will find like all the information from where it is picking the files, which browser it is using to run the test. Like this Chrome, you can run it in multiple browsers. As you can see, this is an array, but you need a plugin like Karma launcher. Go to package.json. We should have a Karma Chrome launcher somewhere. And these are dev dependencies. The reason is you will run test inside in dev environment, not in production. So that's a dev dependency. If you see here, you have Karma Chrome launcher. You can have Karma Firefox launcher. You need to install that even before using that browser. Anyway, I don't see a need to use other browsers. Yep. Any questions so far? Yep. Yes. Thanks, Shashank. I'll talk to you in the next session then on Monday. We have as many as 3 sessions, I guess, left. So see you there. Bye.